Hey friends, I just got this 1915 General Electric motor in today, and I've got it temporarily hooked up through a switch here. These 1915 motors had 3 conductor head wires on them, and in order to start them you've got to go through a choke coil and a switch. You can't just hook a test lead up to 2 of these wires and the thing won't start. It'll burn the motor up if you try to do that anyway. But anyway, this thing's got some problems. I'm going to plug it in and we'll listen to it run. It's got bad bearings in it. So I'm going to disassemble this thing and machine new bearings for it and see if we can't quieten it down just a little bit, make it run a little bit better. Okay, stay tuned. Okay, so we've got the motor apart and we've got the rotor out and we've got it cleaned up a little bit. This is the rear bearing that came out from in there, and it's a little bit egg-shaped, as you can see. So we're going to make a new bearing to put in there. Seeing this reminded me of a phone conversation I had with someone last week. And we weren't discussing GE motors, we were talking about something else, but I asked the fella if it had a double lead thread. Now, this is the worm that meshes with the worm gear that you'll see back up in there. You see that gear up in there? That is called the worm gear. A lot of people will identify this. They'll call this a worm gear. This is not a worm gear. This is the worm. Okay? And some of these worms have a double lead thread. And what I mean by double lead, you'll see that there's 2 starting places. Actually, these aren't the starting places. These are the starting places on this end. You'll notice that one thread starts here on this side and the other thread starts here on this side. So it's a double lead, and they both happen to end up right here on the same part of the shaft. So this is a double lead screw right here. Okay, this just reminded me of something that we were in discussion about last week, so I thought I'd point this out in this video right here. Okay, we're going to commence to making a new rear bearing for this thing, and then we're going to get the front bearing out of there and make a new front bearing, put this thing back together and see if we can't quieten it down a little bit. Okay, stay tuned. Hey guys, one more thing I'd like to point out after looking at this worm a little bit closer. I'm going to see if I can't get as close as I can so that we can see some detail on this thing. Now, if you look at the ends of this thread right here, you see this has got a flat up on top of this. This is the crest up on top, and this is called the root down here in the bottom. This is the root of the thread. This is the crest up here. So if you'll notice, if I can get it to focus, you'll see that there's a flat that's probably, I don't know, 15-20 thousandths wide up on top of this thread right here. This one has a flat, but see, it's a little bit narrower. And as we move to the middle here, where that worm gear runs in here, that worm gear runs right in the middle right here. It only has about 3 teeth engaged at any given time. And see how these come to a sharp point right here? These are sharp. And then as you get on back out here, see how these are flat? These have a nice flat on top, which is what the thread would have looked like when it was newly machined. This has little or no wear here, but these have a lot of wear. See how they almost come to a knife edge almost right here. And this is where all the wear is. If you'll notice that in between here, the space is a lot wider because a lot of this has been worn out. If you'll notice, you see that nice angle in there that's supposed to have, And here, see, you don't see that angle. You see how it's got a lot of wear up against this edge right here, where this shaft is driving that worm wheel and it's wearing against this side. So it wears that away and you lose these flats right here. So you end up with a lot of slop right here in between the worm and the worm gear. It starts getting kind of sloppy and starts wanting to rattle and make a little noise whenever it's engaged and running. Okay, that's all for now. I noticed this wear in there and I thought I'd point this out while we were talking about this worm right here. Hey guys, I've got this bearing roughed out on the lathe over there, and I brought it over here and put it in this fixture to put it on the milling machine. So basically what we did, we just started out with a piece of 3/4 inch diameter brass bar stock. This is solid brass bar stock. And we put it in the lathe and we roughed it down. We roughed it into within a few thousandths of the finished dimensions. And I want to go ahead and drill my oil hole and put my groove in. You'll see the original bearing here that came out of there. So this is what we're looking at it like this right here. If you'll notice, there's an oil hole right here for oil to get into the bearing and lubricate that shaft. And 90 degrees opposed from that oil hole, there's an alignment groove right here, where an alignment pin inside that motor housing. You'll see where that alignment pin is sort of bit into the side of it right there. But these things have to be they have to be exactly 90 degrees opposed to each other. And in order to do that, I'm using a fixture right here. It sort of saves me a little bit of time. There's a 5C collet right here, and here's what the collet looks like if I were to take the collet out. It's got a collar back here where I can tighten it up to squeeze this collet down and hold my part good and firm. Now the milling machine itself takes an R8 collet, and it's a difference. You can see the difference in the two types of collets right there. This is what goes in the spindle of the milling machine. This one is for my fixture right here. So this just saves me a little bit of time not having to use an indexing head, sort of like this one, because this one tilts up and down this way. So you've got, if you can see through all the dirt there, you've got so many degrees. This thing will tilt up 90 degrees. So this thing's got to be indicated in this way. It's got to be indicated in this way. It's pretty time consuming to do these features here on an indexing head like this. So with this little fixture, my vise is already indicated in on the table. So my vise is good and square. All I've got to do is clamp this into my vise, and everything's already aligned. I've got it aligned this way, and I've got it aligned this way. So all I'll have to do is indicate from the end of the part, go back however many thousandths where that hole location is, and come over here, touch off on the edge of my part with an edge finder, and move over to the center line of my part. That's where my hole goes. And then what we'll do, we'll take this out of the vise and flip it over 90 degrees, and I'm already there. Boom, I can start putting my groove in there. So there's a little bit of indicating I have to do to get the, to be sure I'm on the center. But it saves me a lot of time from having to use a dividing head or an indexing head like this. This is a handy little thing here. Okay, here we go. Okay, so we've got the rear bearing all finished up, and we're going to start making the front bearing now, and we'll be ready to start reassembling here pretty soon. Okay guys, so we got the rear and front bearings back in there, and there's the old ones that come out from in there. And I've got everything all back together. Again, we're wired up temporary here with some alligator clips, and I'm going to plug in power and let you hear it run. There you go. Alright, appreciate y'all watching. Y'all subscribe to my channel if you enjoy this kind of thing. Alright, y'all take care.